Good evening. LTE. LTE developed by third generation partnership project. Network infrastructures and mobile terminals designed and upgraded. Goals of LTE are achieving global broadband mobile communications with following advantages: higher data rates, improved coverage, flexible bandwidth operations. Evolution beyond release 8. This project is designed to implement the following features in the present wireless network. The first feature which was thought of to be implemented is long-term evolution multimedia broadcast multimedia service. So multimedia broadcast multimedia service means for broadcasting data both for dedicated and shared carriers. The broadcast type signals OFDMA based, that means orthogonal frequency division multiple access. It may send in the same resource space from different base station, and signal from multiple base stations can be combined in the device. Example is digital video broadcasting. The next feature which Evolution Beyond Release 8 want to develop is self-optimized network. What is the meaning of self-optimized network? Basically, it is an automation technology which was designed to make planning, configuration, management, optimization and healing of the mobile network, so that for any ambiguous or any unexpected problem happens in the network should be capable of overcoming the crisis. It should be able to repair the problem. So that's why it was defined as self-optimized network. The next feature was minimization of drive test, a feature of third generation partnership project. It enables operators to utilize users' equipment to collect radio measurements and associated location information. So minimization of drive test. That means we should be, the future tells that manual measuring of some of the important characteristics of the wireless network should be minimized as much as possible. In this regard, we can take the help of the measurement done by the user's mobile itself, and those parameters can be sent to the network, and those parameters help sent by the users can be taken help for diagnosing the system. Next is requirement for multi-bandwidth and multi-radio access technology base stations. So this is to assess the requirement for the case of same radio frequencies can be used for different kinds of technology. Say we should be capable of using the same spectrum for different technologies like LTE and GSM. One user might be using a GSM, another user might be using LTE. We should be capable of, the system should be capable of using LTE and GSM the same frequency spectrum. Next feature is enhancing support for emergency call. This is for both enabling prioritization of emergency call so as to support emergency call and for position location in LTE network. Now let us see the next concept, LTE specifications and 3GPP structure. What are the LTE specifications? It's just similar to wireless CDMA, that is a radio technology of UMTS, Universal Mobile Telecommunication Services. So this WCDMA uses both FDD and TDD. WCDMA uses channels whose bandwidth is much greater than that of the data to be transferred. Modulation techniques use encodes each channel in such a way that the decoder knowing the code can pick out the wanted signal. We already know about CDMA. CDMA technology, we are actually modulating the signal twice. That means once we are mixing the signal with the pseudo noise sequence, that means PN sequence. Which you people might have learned in your earlier graduating course. After that, it is modulated later on either using PSK or QPSK. UMTS uses core network derived from that of GSM, ensuring backward compatibility. 3GPP evolution background, combination of high speed data packet access and EDCH, which means enhanced dedicated control channel. So these two provides very efficient transmission capabilities. Now evolved UMTS will make business sense if it provides significantly improved power and bandwidth efficiency, facilitates the convergence with other networks, and reduce transport network costs, thereby limiting additional complexity. So if you are capable of combining technologies like HSTPA and EDCH, we should be able to provide the significant improvement with respect to power and bandwidth. Interoperability with legacy system. EUTRAN interoperates with other technologies like GRAN, UTRAN and EHRPD. Interoperability with other radio access technology is possible at the IP level. Different interoperability mechanism for different deployment options are inter-RAT handover, network access cell range, single radio voice call continuity and circuit switched fallback. So this is our basic system architecture configuration with only EUTRAN access network. What we are seeing in this network? This is the user's mobile, which is first wirelessly connected to EUTRAN on the U interface, and the EUTRAN connected to the evolved packet core network on the S1 interface. Remember, each interface is being supported by a protocol. Then this evolved packet code is networked with packet data network on the HGI interface. EUTRAN their interface of 3GPP, acronym for Evolved Universal Mobile Telecommunication System. This is also known as Evolved Universal Terrestrial Radio Access Network. So whatever network we are seeing now, it is referred with these two names. So this is one typical diagram of this EUTRAN. What we are seeing in this diagram, starting at the lowest level, it is the user, which is wirelessly interfaced to the EUTRAN, this network. This EUTRAN consists of E node B. This is one E node B and this is another E node B. These two E node Bs can be wirelessly connected. This feature was not there in the earlier GSM network. Suppose this mobile is connected to this E node B and it want to communicate to one more mobile which is connected to this E node B. Earlier in this case, this mobile used to go through all these interfaces and get connected to this, thereby creating latency, so also consuming more bandwidth. So presently what it will do, these two E node Bs, which are similar to the radio network controller, are wirelessly connected on the X2 interface. The user, if it want to connect to other user which is connected to this E node B, this is possible now. And after through this E node B, it is connected to mobility management entity. You can see this mobility management entity, then it is connected to service gateway, then through this to the other network element like PCRF, PGW, which we are going to see later on. So all these nodes together is formed evolved packet core. Then this is connected to the highest hierarchy, that is services. So here there are elements which are responsible for giving as services to the mobile. System architecture configuration. New developments in EUTRAN radio access network, evolved packet core network, EUTRAN, EPC, UE, all this combination forms internet protocol connectivity layer. This is responsible for giving connectivity. Say for example, for supporting voice over IP. That means in LTE network, voice is carried out on the same channels that is going to carry pictures and video. So this technology is called as voice over IP. User equipment. Handheld device contains the SIM, which is going to define and identify the user and authenticate the user. EUTRAN mesh of eNodeBs. All radio functionalities will be there in this mesh of eNodeBs connected to neighboring eNodeBs as I shown earlier. This eNodeB is connected to this eNodeB. So this is what it is.